we move to the first example. So this example is a circuit consists of 5 op-amps. So we have 1, 2, 3, 4, 5 op-amps. So the first question, sub-question is name the function of each op-amp. So we have learned that op-amp can be used in various applications, or this is what we call it a function. So we want to name all of these 5 op-amps. Okay, for the first one, so op-amp number 1. Okay, op-amp number 1 has one input, and then input is connected to the inverting. And then we also have the negative feedback. So this is the inverting amplifier. This is inverting amplifier. Okay, for op-amp number 2, there is no resistor used. There's no resistor used. And then so this one no resistor used. And then we have here, so we don't have any branches in the inverting or in the non-inverting port. So this is where the V plus is equal to V minus and V minus is equal to V out. So V out, eventually the V out will equal to V in. So this is what we call a voltage follower. Okay, so number 3 input is at non-inverting input port, and then we have the negative feedback here, and this is a single input, so this is a non-inverting amplifier. This is amplifier, but the gain is positive. For number 4, the input is, we have the multiple input. So V out 1, V out 2, and V out 3 will be the inputs of the op-amp number 4. So the input is going to the inverting port. Then we have negative feedback. So this is the summing. So we sum all these 3 amplifier, all these 3 voltage. So this is summing amplifier. So and then the last one is number 5. Number 5, we have the multiple inputs, and the input, some of the input are connected to the positive, the non-inverting, and some of the input is connected to the inverting input. So this is the differential or subtractor. Yeah, this is subtractor. Okay, so this is the naming of each function. So next we want to determine all the output voltage, V out 1, V out 2, V out 3, and then we have V out 4, and we have the V out 5. Okay, to analyze this type of circuit, we can do one by one individual op-amp. So we start with the op-amp number 1. Okay, as we have discussed before, for the DC analysis, we need to do the KCL. To do the KCL, you need to label the current. As I put this is I1, and this is I2. So the KCL is, so I1 and I2 both entering, I1 plus I2 equal to 0. And then I ignore this one because this is equal to 0. The input current is 0. Okay, what is I1? I1 can be expressed using the Ohm's law. This is voltage across the 1K. So 2 minus V minus over 1K plus I2 is V out 1 minus V minus over 2K equal to 0. So here we have the voltage V minus. So here V minus is equal to V plus, which the V plus is ground. So this is a virtual ground. So this is ground. So what happened? So this will be 0. We have this equation, and finally we can get the answer. This is minus 4 volt. Okay, so next we do the op-amp number 2. Op-amp number 2 is very straightforward. So we start with the input. The V plus is equal to 2 volt, and then we know that V plus is equal to V minus, and V minus is equal to V out 2. So therefore V out 2 is equal to 2 volt. Okay. So we have known that this V out 1 is next we go to the op-amp number. Oh, I skipped the number 3. Wait a minute. Okay, we do the op-amp number 3. So op-amp number 3 is, we only focus this area. Okay, so we do the KCL, and then right now the KCL, the node is here. So let's say I put this is I1 and this is I2. So the KCL is I1 is exiting, I2 is entering. So minus I1 plus I2 is equal to 0. So I1 is Ohm's law, defined by the Ohm's law. So this is minus V minus over 1K plus I2 is V out 3 minus V minus over 1K equal to 0. Okay, here you know that the V minus is equal to V plus. This is equal to 2 volt. Okay, this 0.5 kilo ohm will not does not matter because the current is 0. Okay, because the input current is 0. So so the equation will be the minus 2 over 1K plus V out 3 minus 2 over 1K equal to 0. So this is 1K and 1K. So finally you get the V out 3 is equal to 4 volt. Okay, now you know we have calculated V out 1. Until now we have calculated V out 1, V out 2 and V out 3. Okay, V out 1 is minus 4, V out 2 is 2, V out 3 is 4. So we go to the op-amp number 4. So I put the value for the V out 1 is minus 4 volt. V out 2 is 2 volt. V out 3 is this is V out 2 and then V out 3 is 4 volt. So we do the op-amp number 4. So the KCL, label the current first. This is your I1, this is your I2, this is your I3, and this is your I4. Input current is ignored. So all of these currents are entering this node. So this node and this node and this node are the same node. So the KCL here is I1 plus I2 plus I3 plus I4 equal to 0. And then Ohm's law, using the Ohm's law, I1 is minus 4 minus V minus over 2K. So this is the I1, and I2 is 2 minus V minus over 2K. I3 is 4 minus V minus over 2k plus this is V out 1 minus, sorry, V out 4, V out 4 minus, okay, V minus over 2k. This is equal to 0. So all the resistors are 2k, so this equation can be ignored. And then here the V minus is equal to V plus is equal to 0. So you got here, this is minus 4 plus 2 plus 4 plus V out 4 equal to 0. So the V out 4 is equal to, this is equal to minus 2 volt. Okay. You can check that you have the answer here. Okay, so this is V out 4. Okay, lastly, we do the op-amp number 5, which is a subtractor. So we know that V out number 4 is minus 2 volt. So this is minus 2 volt. So as KVL, KCL. It's not KCL. KVL is KCL. So we label the current. This is I1, I2, I3, I4, I5. Okay. So we have here, we have two nodes, this node and this node. Okay. So in subtractor, it's better to start with the node, the positive node. Okay, the non-inverting node, because it don't has the feedback, so you only have the input parameters. Okay, we do the KCL. I put this is node number 1, so this is KCL for node 1. So I4 is plus I5 is equal to 0. Okay, I4 plus I5 equal to 0. So and then I4 is 2 minus V plus over 2k. This is I4. And then I5 is 2 minus V plus over 1k. This is equal to 0. Okay, so now you can get this one is 2 minus V plus plus 4 minus 2V plus. So V plus is equal to 2 volt. Okay. This is from node 1, you can get the V plus value. So next you do the node of the node number 2, KCL node 2. So this is I1, I2 and I3 all entering the nodes. So this is I1 plus I2 plus I3 equal to 0. Equal to 0. So I1 is, this is minus 2 minus V minus over 1k. And then I2 is 6, yeah, 6 minus V minus over 2k. And I3 is V out 5 minus V minus over 2k. Okay, so this is equal to 0. So V minus is equal to V plus is equal to 2 volt. So here, we know that okay, so we insert the equation, so to insert the value, so we get this is over 1k plus 6 minus 2 over 2k plus V out 5 minus 2 over 2k 0. So the calculation, you will get V out 5 is equal to 6 volt. Okay, so this is the answer.